Am I on the right site? It's a little tough to hear with that piano in the background.
Oh yeah, I'm out of there now.
Okay. So I'm at the Ralston Valley High School. Now where?
You see the teachers' websites?
Uh-huh.
You click on that.
Okay.
And you're going to find Miss Emily Dritz.
Are we going to math first?
Yeah, math.
Okay. Let me save this, just so I can get back to it if need be. Who are we going to?
You're going to go to
Emily Dritz. Go to her website. You said Emily Dritz,
yeah.
right?
Yes.
Okay. Now what?
And then you're going to go to Algebra 1 once you're on your website.
Up here in the left, or this Algebra 1? That Algebra 1 probably. Okay.
Up in the left.
Well, I think I went to the same place. I should have. You doing these? You doing exponential functions? Now I got to go down the calendar to April.
See if there's anything.
Today's April 5th. Functions. Homework. What do we want to? Let's go to homework.
Yeah.
Because I can tell you how the rest of the stuff. All right. And these are problems you have not done yet?
No, I've not done those yet.
Okay. So let's talk about, in fact, let me use my new toy here. This is cool. I just discovered this the other day that I could do this. On number 1, the solutions for each system are going to be that intersection point and that intersection point, right?
Yeah.
In other words, wherever they cross, doesn't matter how many times they cross. Well, what I've got is the equation of the parabola is y equals x squared minus 1. And I've got the equation of the straight line is y equal minus x plus 5.
All right.
So if I solve this system of equations, I will solve for the x value, and it should give me 2 different x values. I can see that the x values should come in at 2. And the other x value looks like it's going to come in at minus 3, right?
All right.
So that's one thing we can do and since they gave you a graph, I don't see any reason for us to do anything but that.
All right.
So the solution for that problem is x equals 2 and also x equals minus 3.
All right.
And they didn't really ask for a y value, but if they want it, the coordinates are 2, 3 and minus 3, 8. You see where I'm getting the y value?
Yeah.
Okay. In other words, if they want both points. And usually when they ask you to solve a system of equations, there's 2 variables, x and y. And so you really do need to solve for x and y. But notice the dilemma here. In other words, when I first solve for x, I get x equal 2 or minus 3. Well, I have to go back in and plug in the 2 to see what y is, and y would have been 3. And then I got to plug in the minus 3 to give me a y of 8. And this solution set is exactly that. It's not 4 separate numbers. It's 2, 3 is one solution, And minus 3 comma 8 is another solution.
All right.
Okay.
Okay.
The second one. Again, let's do it graphically. What is this solution right here? Give me both coordinates.
Let's see if I can read that.
Yeah.
One is,
I could normally blow it up, but not. I'd have to back out of this thing, and let me do that. Hold on a second. I can do this. I'm going to zoom once, okay, and now I'm going to bring up that tool again. There. Now, what's this point right here? Where they intersect.
one is 0.
What's the x-coordinate? Always go from the x-coordinate to the y-coordinate. This one, right here that I'm...
Minus 4, 0.
Okay. That's that point, and what's this point down here?
0 minus 4.
Okay. That's what I want. Is always go left to right. In other words, always give the x-coordinate first.
Yeah.
Now, let me scroll down. Yeah, I don't need a separate paper here. I'll just work on this. I love this thing. It keeps me from having to rewrite all these equations.
Yeah.
And I've had it all along. I just didn't know I had it. I was fooling around with it the other day and realized I could do this, and I was thrilled. So, how are we going to answer this? Do they care how you answer this, or when they give you a multiple choice, is the only thing that matters getting the right answer?
I think it's just getting the right answer.
Okay. Because it matters. If you're taking the SAT test, then it's only getting the right answer that's the only thing that matters.
Yeah.
And if you have two ways of doing this problem, one of which takes 2 minutes and the other of which takes 30 seconds, you choose the 30-second method. Now, if you've got a teacher that wants you to keep track of the way you solved it, different story. But usually when they give you multiple choice, you can do it however you want. So how would you do this problem?
I would just go through each point and solve it for the easier equation.
Exactly. In other words, what a lot of high school kids call check and guess. Or guess and check is really what they should call it. I call it back solving. Okay?
Yeah.
In other words, does that, let's try something really easy. Does that fit that problem? Hold on a minute. Hold on a minute. Let me look at this again. What the question is asking is one of these 4 points has to work for both equations. And by work, I was going to say equals 0, but yeah, okay. Yeah, in other words, they're really saying that equals 0 and this one equals 0. Which set of points satisfies both equations? Let's take this first set here. Does that work for f of x?
Yes.
Okay. Does it work for g of x? minus 3.
Oh, well, yeah, it does.
Yeah, because that becomes 0, and 0, doesn't matter what this is, 0 times anything is 0.
Yeah.
So we're done. Boom, 30-second solution. I didn't have to create a quadratic. I didn't have to fool around with setting these equal to one another. You still there?
Yeah.
Okay. Oh, that was just a notification. Sorry. And we're done. They were nice enough to make the very first one we tried work. Now, there are a few things that are worth looking at here. And that is that can't possibly work because that does not make either of these two terms 0. So we know that whatever solution we come up with has to make one of those two terms 0. Well, that doesn't do it. That doesn't do it. And that doesn't do it. The only one that even comes close to making one of those two terms 0 is when x is minus 3. So in a way, you can almost solve this thing in a multitude of ways. But either one gives you A as the solution.
Yeah.
All right, now they want us to solve it algebraically. When they give you two functions that are both y equals, that's the same y. This y equals this y. So what should I do here?
Only define 2 points that can...
No? In other words, they want us to solve it algebraically. That means I either got to use substitution or I got to use elimination.
Yeah.
Well, if y equals that and y also equals that, then doesn't this have to equal this? And by what I'm trying to say here is I sometimes point with my cursor thinking you can see it and you can't always. That has to be true. Why do I have such weird ink here? Okay. Anyway, now we have a quadratic to solve. Let's solve this. Read me the next line.
Alright. 6 equals...
No.
2x plus 10.
Hold on. Whenever you're solving a normal quadratic, you're setting one side equal to 0 and putting everything else on the other side. Don't forget that. That's a huge principle in solving quadratics. So let's gather everything on the left. Well, I've only got 1x squared. How many x's am I going to have after I move this 2x over?
You're going to have 3 x's.
Minus 3. Because in order to move it over, I got to subtract 2x from both sides. And what number am I going to have?
Minus 4.
Okay. And there's nothing left over here because I subtracted everything. So there's 0 left over. Now, the reason you do quadratics this way, setting everything equal to 0, is because now I can factor this and solve it. If I don't have it equal to 0, well then it doesn't do any good to factor it. Because if I have two numbers multiplied together equal to 4, I can't do anything with it. The only thing that ever works is if you can get it equal to 0. And then you can say, well, one of these two things has to be 0. So how does this factor?
X and then 1's plus 1's minus. And then
we're looking for factors of 4 that subtract, because of that negative sign, to the number 3. So it's 4 and 1. The bigger factor goes with the sign of the middle term. So the 4's got to go there, the 1's got to go there. Now, we've got two different solutions for x. What are they?
Oh, jeez.
Set that one equal to 0. What do you get?
You get. I know this. Why am I not getting this?
Just having a moment. If you set that equal to 0, this is what you want to do. You want to go x plus 1 equals 0. Now solve that equation.
X plus 1 equals 0.
Solve that for x.
Minus 1.
Okay. That's simple. Now, what's the second x?
X, so plus 4.
Okay. Now, for each of those x's, we have to come up with a y.
Sure.
So, what is y when x is minus 1? Which equation are you going to stick it in for? First one or the second one?
The first one.
Second one's a lot simpler. It's the same y. So we can plug it into either one. But notice that we have to substitute minus 1 for x. Well, which one is the easier math? The top one or the middle one? I mean, the top one or the bottom one?
The bottom one.
Okay. So what's y when x is minus 1?
X is minus 1. Y would equal 0.
And to this function, plug a x of minus 1 and tell me what you get for y.
The what function?
To this one that I'm circling. Plug in an x of minus 1 and solve for y.
It would be minus 8. No, it's just like 8. Y equals 8.
Okay. Now, for the second value of x, do the same thing. What is the y when x equals 4? Plug it into the same function, the same easy one.
It's going to be 18.
Okay. Notice that that math was easier than plugging it into this quadratic. Right?
Yeah.
That's why I chose the second function. You could have chosen either one. But our solution is now minus 1 comma 8 and 4 comma 18. And that's kind of the way you have to write it. Because it's not just 4 numbers. It's this x and y go together and this x and y go together. Okay. Let's look at the next one. Again, these y's are the same. So what's the next thing I can write? In other words, we can still follow the theory of elimination, right?
Yeah.
In other words, the goal with elimination is to eliminate a variable. If you can get it down to one equation and one variable, you got it solved. It's only when there's two equations and two variables that there's any problem.
Yeah.
Well, I can eliminate the y immediately by doing what?
Is it just having the opposite of whatever the number is?
No. If that y is equal to that, and the same y is equal to that, then what can I say about those two things that I've circled? They have to be equal to one another.
Yeah.
X minus 1 squared minus 33 has to be equal to 4x plus 8. In other words, I've eliminated the y. And I can eliminate it because it says y is equal to that. If I said y is equal to a and the same y is equal to b, then you would know that a has to be equal to b. That's all we're doing.
Alright.
Okay. Now we got to solve this quadratic, and we know it's a quadratic because I can see that squared term there. So when I square this linear term, I'm going to end up with an x squared term. That's going to make it a quadratic.
Yep.
Okay. So the next thing to do is to solve this quadratic. All of these problems are somewhat the same, as you end up with a quadratic which produces two x solutions. All right, so first of all, expand this. In other words, here's the thing, Nick. If you know that that's going to give you an x squared, and you can see there's a 4x over there, and we've got all of these other numbers, we know we're going to end up with a normal quadratic. So the way to solve it is to expand it and then collect everything on one side, just like we did the last one. Okay? So first of all, we got to expand it. By expanding it, I mean let's get rid of that exponent. So what's x minus 1 squared?
X minus, and we're just squaring both x minus 1.
What does this mean, x minus 1 squared? It means x minus 1 times x minus 1. That's what it means. So that's what you have to do. What do you get when you do that?
X minus 1 times x minus 1.
Uh-huh.
You get x squared minus 2.
No. FOIL it. Every term by every term. In other words, you got to multiply that term by that term, and you got to multiply that term by that term, and you got to multiply this term by that term, and then that term by that term, and add all four together.
Okay.
That's what foiling is. Now, you might not have been actually taught FOIL. Some schools don't use that terminology anymore because it doesn't work very well when you have 2 terms times 3 terms. But what FOIL means is first, outside, inside, last, which is what each of those arrows that I drew are. The first one multiplied x times x. The outside multiplied x times this minus 1. The inside multiplied this minus 1 times x. And the last multiplied this minus 1 times this minus 1. So when you do all of that, you get x squared minus 2x plus 1. So all I've done is just part of the problem. Now, I don't need these parentheses anymore, so let's erase them. They're not required. In other words, they don't change the problem to erase them.
Yeah.
Now, what's the next step?
The next step is to get everything onto the
Okay.
right side.
Well, let's get everything onto the left side. The reason I say that is because we've already got the most important term on the left side, and it has a positive coefficient. That's key.
Yeah.
We don't want to deal with negative coefficients for our x squared term. In fact, if you ever find yourself with a negative coefficient, divide everything by -1 and turn it positive. Okay? So let's bring everything over to the left. Tell me what the next line is. I'll even give you a start. Hold on. Got to make sure I'm in pencil mode. That's the first term. What else?
So the first term is x squared. Next would be minus 2x plus 1 minus 2. So are we keeping the 4x plus 8 on the left side?
Nope, we're moving everything to the left. But you can only combine like terms. So you can combine that 2x and the 4x that's over on the right side. Combine those together. And then combine your numbers, all of them together. So that you have an x squared term, you have an x term, and you have a number. Just like every other quadratic that you've ever seen. So what's our x term? When I bring the 4x to the left side, what does it become?
It just becomes minus 2x squared.
It's minus 2x minus 4x, which is minus 6x.
Yeah.
Now, bring all of the numbers over. Well, those two numbers turn into minus 32, and I'm going to bring in minus 8 over, so that's minus 40. I moved everything over, so what's left over is 0, not 1. Okay, now we got to factor that, because only in factoring am I going to be able to know my two answers.
Yeah.
One's plus, one's minus.
Yes.
What are the two factors?
The two factors are going to be... Hold up, my computer's glitching.
Okay.
Everything's like frozen.
That's no good.
What in the world? Oh no, we're good now.
Okay.
Alright, so what are the two?
Yeah, factor x squared minus 6x minus 40.
Alright, well we have x, so numbers that multiply to, so it'd be 10 and 4.
Okay, good. Where's the 10 go?
The 10 goes in the minus and the 4 goes in the plus.
Okay, what are my answers? X equals what?
Hold up, the computer just like went down again. Just shut it turned off.
Tell you what, since you're having computer problems, why don't we call it a session?
Alright.
And we'll pick it up again next week. You might.
Sounds good.
Do you live with your sister? I mean, can you use her computer for your sessions or not?
I would, but she's usually at studying and she's not home right now.
Okay. All right. Because that'd be the best thing to do, both for the audio and to solve your computer glitches. You're dealing with an awfully old computer, I suspect.
Yeah.
All right, Nick. I will talk to you next time.
Alright, I'm good.
Bye-bye.
Bye-bye.